we're going to learn how to use the distributive property when we simplify. Okay? Now, what do I mean distributive property? The process of distributing the number on the outside of the parentheses to each term on the inside. Look here. What do I mean? When I'm multiplying the outside number by every number inside the parentheses, that's what it means. This is the distributive property. Okay? So, what do these parentheses tell me to do? What operation is that? It's a what? Multiplication. Very good. So here, A times B. What do you have in the middle? Plus A times C. Okay? And if you have the number multiplied from the other side of the parentheses, we're going to do the same thing. B times A. Okay? Plus here, then C times A. Any question about the distributive property and how it works? The same thing with subtraction. If you have an outside number and inside the parentheses we have two numbers or two terms subtracted, we multiply the outside, A times B, then minus A times C. And the same way, if the number was multiplied from the other side of the parentheses, it's the same thing. B times A, this is times in between, minus the middle sign, then C times A. Any question? We're going to take examples. Now, 5x plus 7. Pay attention, please, all of you. But I don't know why you're writing this. Don't write this. When I give you examples and I ask you to solve it, just do this, please. Now, if you have an outside number, what did we say about distributive? What do we need to do? Multiply the outside by the inside. Good job, Diamond. Okay? So that's going to be what? What's 5 times x? What's my middle sign? Symbol. Plus. What's 5 times 7? Done. Okay? 1. Jose? Come back to class, okay? Now, you do this and show it to me, please, on the whiteboard. 3m minus 4. Marco, come on, buddy. Leonard, your business is not going to stop in my class, okay? Put this away, I don't care. You're going to lose the lottery now. Put this away. Do this, please. Multiply the outside with the inside. Did you do it? Yes? No? Good job, Donovan. Did it. Good job, Mike. Excellent. Ah, yes, excellent. Okay. All right. Martha, what did you get? Very good, very good. Listen. Oh, yes. All right, Maxie. Why did you have a whiteboard? How can I see it? And what is yours, mister? Show it to me. What is your answer? I can't see it. Show it to me. That's why you have a whiteboard. Lavana, what did you get? Okay. Pay attention, okay? Look how we do this. We multiply the outside with every number inside. Oh, that's better. Yes, yes, thank you. Now, 3 times m is 3m. My middle symbol or operation is minus. 3 times 4 is 12. Oh, it's m, no man. You're right. Okay? Any question? What do you have in this board? This bowl? It's dirty. Throw it away. Now do this, guys. Negative 2, y plus 3. remember, these two parentheses tell you to do what? Multiply the outside with the inside.
Yes.
Yeah, this one deposits lots of them.
It's false, it's false. All right. Good. Why is upside down? Okay, good.
So is this right?
I think good. Good. All right, pay attention, guys. Some of you had mistakes. Pay attention. So what I do, I multiply the outside with every number inside, right? What's negative 2 times y? What's my middle operation? What's negative 2 times 3? What's negative times positive? 2 times 3 is 6. Now, what's plus negative? Can I change it into subtraction? Do you remember when I say subtraction is the same as adding the negative? Subtraction is the same as adding the opposite. If you read it this way, that's right. If you do it like this, that's even better. Okay? Hello. Very late. All right. Now, look at these questions. Which statement demonstrates the distributive property incorrectly? Which one of these statements is wrong? Let's look up here. If I do the first one, and I do the distributive property, what do? What's 3 times x? What's 3 times y? What's 3 times z? Is this right?
Yeah.
Yes. Okay? Now, let's do this one. A times c is plus b times what? B times C is BC. Is this right? Let's see this one. 5 times 2 is plus 5 times 3x is. Is this right?
No.
No, that should be how much? 15. That's wrong. Let's do this one. 6 times 3k is
18K.
minus 6 times 4 is
24.
this one is right. Okay, see how we check our answers, Max?
Yeah.
Now, let's go over some definitions. When you hear me talking about terms in math, terms meaning a number. If I say 5, this term, you tell me, you know I'm talking about specific thing in math. Could be a number, could be a variable, could be a product between a number and variable. What do I mean a product? What do I mean a product? Answer to it. To multiplication, very good. So if I say a product between a number and a variable, let's say 5x, this is a product. If I say a quotient, what do I mean quotient? Division. So if I say 5 divided by x, also this is a term. All these things, we call them terms. It could be a number, a variable, a product, or quotient. So these are examples. 5 is a term. M is a term. 2x squared, 2 times x squared is a term. 5 over y to the third power, that's a term. Okay? What do I mean coefficient? Coefficient is the numerical part of the term. Now, what do I mean numerical? It means what? Numerical means what? A number. So if I say what's the coefficient for this? What is the coefficient? How much is it? 4. 4 is the coefficient, right? the number multiplied by the variable. We call it the coefficient. Sometimes with some story problems or with some number problems, they say, what's the coefficient for this term? You should understand what the term is. This is a term. 4a by itself is a term. It's a product between a number and a variable. 4 by itself, this is the coefficient. Just a number is the coefficient. Okay, Markwell? All right. Now, what's the coefficient? Who can tell? Who's this smart person? Don't blurt out. Just tell me. Where is the coefficient? How much? Raise your hand and tell me. Raise your hand. Just call. Come on. What is the number in front of y squared? You see the 2 in front of y squared? The coefficient usually is in front of the variable. In front of.
Oh, so there would be.
Oh yes, did you hear anything? What's this number? Excellent, that's a 1. There is no number, that's a 1. Okay? 1 is the coefficient. Good job, buddy. Did you hear it from these guys? Or you figured this out? Okay. All right, what's the coefficient here? What's it? 5? Just 5? Do you see any other number other than 5? So what's my coefficient? It's not 5, it's not 7, it's 5 over 7. 5 over 7. This is the coefficient. Okay? So the coefficient is the numerical part, meaning the number in front of the variable. This is the coefficient. If there is no number, what's my coefficient? 1. Okay? Like terms are terms with the same variable and exponent. I'll show you what that means. Look at these two terms. The first one is a term, right? It's a product between a number and variable. And the second one is a term. But are these like terms? Let's look. First of all, I look at the variable. Do they have the same variable?
Yes.
Are these variables raised to the same power? Raised to 1, right? Are these like terms? Can they hang out? Can they be combined? Okay. So what's 13k plus 22k? How many k is that? 13 and
Also 5.
35k, right? Those are basically like terms. Okay, because they have the same variable raised to the same power. What about those? Yes or no? Are they like terms or unlike? Shh, don't blurt out. Think. Look at them. 5ab and 4ba. Are these the same variables raised to the same power? Let's see. Do we have a here? Do we have a here? What's the power of a? What's the power of a? Also, we have b and we have b raised to what power? Are these like terms? Yes, they are. They are like terms. They have the same variables raised to the same power. I don't care about b and a. If b was 2 and the other b is 2, those are like terms. The same variable raised to the same power. Okay? What about those? X to the third, y, and x times y to the third. Are these like terms or unlike? What do you think? What do you think, Lovana? Like or unlike? Like? Unlike? We'll see. You have x here raised to what power? And you have x here raised to what power? 1. Are these like terms? No. Because one of them raised to the first, one of them is raised to the third. Also, if you go to y, let's see y. Y here raised to what power? And here raised to what power? Are these like terms? They should be the same variables raised to the same power. Okay? So those are not like terms. All right. Which of the following is the simplified form of Negative 4x plus 7x. First of all, are these like terms or unlike? Let's see. That's x to what power? That's x to what power? Are these like terms? Can they be combined? What's negative 4 plus 7? 4 zombies and 7 people. Who's going to win? By how many more? So what's my answer? Good job. Okay? Is this hard? Combining like terms? Now do this. Show it to me, please. This is your marker? I got it. Jose, did you do it? You're on? Good job. Okay.
8x plus 2x. 8 plus 2. Square.
8 plus 2 plus
5a plus a.
This is a marker. All right, that was a good. Guys, this is not place. So here, first of all, I know which ones go together. They are like terms. I know x to the second and x to the second. They are sisters, right? They're not brothers. They are sisters. Now they go together. What's 8 plus 2? That's 10. Okay. Do we do anything with the exponents? No, we don't change the exponents. Okay? Just like we're adding 8 markers and 2 markers. How many markers? 10 markers. Do I change the markers into pencils? No. Now, plus 5, 8, and how many A is that? What's my coefficient here? 1. Good job. You understand what coefficient means, right? That's good. Now 5 plus 1 is 6A. Now, do these go together? Can you combine them? No. One of them has x to the second, one of them is A. Absolutely no. Simplify. Good job. Good job.
I mean, I don't. So that would be like divide everything by 100.
You're adding 5, 8, just 5 markers and 7 markers. How many markers?
Oh yeah. Sometimes I remember like what's the thing where like you like that only when you like wonder about one side.
We're just adding.
Oh yeah, there you go.
All right. 5A and 7A. How many A's is that? That's 12 then. Okay? You're
Oh
good?
yeah, I missed one.
By the way, you're not the only one. 5 people in my previous period told me it's that person. All right. Now let's do this. 6.1y minus 3.2y. Yeah. You know what? I was talking with the other teachers that we do the quizzes and everything. And the quiz, he said, I'm going to postpone it till Monday, and calculators will not be allowed. So please just try to do this. Okay, excellent.
I'm not done yet. I'm almost done.
All right, 1 more minute. Are you recording?
Yeah.
In case.
Are you? That's what I got.
It was misunderstood.
So then I supposed to,
You're gonna do the distributed property, yeah.
no, I was supposed to learn how to build the guy coming in.
Okay.
Because right now it's no visual. It's just voice.
Okay, just audio.
Mhm.
There is any, like, there is a camera here. Mine doesn't have a camera.
Yeah. I mean, I
I don't know. You can turn the camera on.
turn it on.
Yeah, if
You
you
want it on?
Who's on?
Do you want it on you?
Who's on?
This is the old one. This is the old one. You're live now. Is this touchable? Okay. I thought I can change. All right. How much is my answer? 2 point. What? Why? Excellent. Good job. All right. Now do this, please. 4x squared y plus x squared y. Pay attention. What's my coefficient here? What's my coefficient? Coefficient for the second one. The first one is 4, and the second one is what?
1.
Good. Are these like terms? First of all, are they like terms? Do they have the same variables raised to the same power? Mhm. Good. Good.
So the 5x.
No, why 2y? Just 5x squared? No, it's just like you're adding 4 markers and 1 marker. How many markers altogether? Yep.
Oh, okay.
All right, so my answer is what? What's 4 plus 1? 5 x squared y. Why are you adding y? It's just the same term. Are these 2 terms or 1 term? This is 1 term and this is 1 term. So we're combining them, so we get 1 term. When we combine them, we get 1 term. Okay? Do you see your mistake? Do you understand your mistake? All right, do this down, please. See which ones go together first, which ones are like terms. So you can combine them, and from there, do the work. Are these all like terms? How did you combine them though? You have 1 term. You have 2 terms.
Yes, it's both. It's both.
I don't know. I'm gonna do it now.
Wait, I'm almost done.
That's confusing, right? Is this problem funny?
It is.
All right. Let's see. Everybody, pay attention, please. Put the cap on and look at the board. Thank you. Now let's see which ones go together. This is m squared n. Let's see which one is m squared n. This is also, right?
That's right.
So those guys, do you have any other m squared n? No. So those go together. They have the same variable raised to the same power. Same variable raised to the same powers. So those guys, they are related. They can be combined. So 3m squared n plus 7m squared n. How many do I have? That's 10 m squared n. That took care of this part and this part. Okay? Now the other two are also like terms. This one is n squared, n squared. Those are like terms. They could be combined. So 10 minus 4 is what? 6 positive or negative?
Positive.
All right. We have two. We started with two different terms, so we have to end up with two different terms. All right. Any question? Now do this. 13a plus a plus 6b. If you have a small letter a, don't write it capital A because that means it's a different variable. The way you see it, write it down. Okay, well, so the A is small letter and the B is small letter. The way it's written for you. Are you marking me? All right. Now, I know these two go together, okay? So 13 plus 8 is how much? 21 back, okay? 21a plus 6b. Can these go together? No. Okay. What time to go? 09. We still have time.
You know, what time?
11:09. All right, do this now. See which ones are like terms. And combine them. Oh, yes? You know what to do? Let's think. Doing good? I love those boys. I don't know. They're very polite. They're very polite. You and you, very polite.
Yeah.
You too.
Oh. How's it five? It's 3. Oh yeah, it is. It is. It is. He's ready. He's ready. What do you mean? Is that right?
Okay. Yep. Why is minus? Why minus? Why minus? No. Who cares about where the minus is? Okay, pay attention. Okay, I'll show you how to combine like this. This is a common mistake. Pay attention. So I go 4D and minus D, right? You see this D? Positive or negative?
Positive.
Minus D. Minus. How many? What's my coefficient?
1.
Okay? Now, 4D minus 1D is what? 3D. Plus. I did it plus. I don't know if it's plus or minus. Let's see. That's 6a squared and 12a squared. How much is that? 18. Positive or negative?
Positive.
So that's plus 18a squared. All right? Not because it's in the middle, I have to put my minus. I would put it in the middle because it's in the middle.
Sorry.
Okay? Did you get that? Okay, do this now. 3y over 4 plus y over 4. That shouldn't be hard. Not. Come on. Okay, how much is that? 4 over 4.
1y over.
Okay, can you simplify it, please?
Yes.
Good.
So,
Isn't that why we have the denominators? When we have like, when we have the same denominator.
Why you putting so much?
we're gonna go all the way to 1 then?
You're adding.
Oh, yes? Max, did you do that? Are you going to do that? How much did you get? Huh? Okay, can you simplify? Oh, do we add the denominators, Max, when we have like denominators? Good job. All right, ladies and gentlemen, pay attention, please. Now, I know when we add the fractions, we look at the denominators. Are they the same?
Yes.
Do we play with the denominators in there?
No.
So what do we put? 4. We don't add them, they're the same. Now, we add the tops. That's the coefficient, how much?
1.
What's 3y plus 1y? What's 4 divided by 4? Or just 1. Okay? All right. Now, which of the following is the simplified form? Do this, please, and show me which one is the right answer. Come on, boys. Please do this, honey, because this one is important. This one is confusing because we have minuses now in the middle, on the edge.
All right, yeah, got it.
Let me see it. Right. Okay, the x and the x, when they go together. Okay, what's 5x minus an x? Okay, are you done?
Yep.
No? All right, let's see which ones go together. First of all, I look for like terms. This one is an x, this one is an x. To the same power, to the first power. Now, look how I do it. Everybody, put the caps on, look at the board, please. Talking. Now, so this is 5x. The sign, the front sign belongs to the next term. The front sign belongs to the next term, okay? Now, what's 5x minus 7x? What's 5 minus 7? 5 people and 7 zombies. Who's gonna win? 5 people and 7 zombies. Who's gonna win? By how many more? So that's going to do x took care of this and this. Now, negative 4 plus 14. 4 zombies and 14 people. Who's gonna win? By how many more? Will that be plus 10 or minus 10? So where's the right answer?
On my board.
Okay? Alright, come on. Hey, to find the perimeter of a triangle, you add all sides. To find the perimeter of a triangle, perimeter of any shape, what do? You add the sides. So, if you have a triangle has these sides, 3x minus 2, 5 minus x, and 2x minus 5. Find the perimeter. How do I find the perimeter? What do I do to these sides? Around the shape, you add them all, and see which one is right. Write them down. Gustavo, come on, write them down. What? The problem, you need to find the perimeter of this side. So you need to find
What? That's what, is it 3 negative?
what's the
Is it?
problem. Do you understand the meaning of this sign? I'll show you. I'm gonna draw you a picture. This is a triangle, right? This side is 3x minus 2. I don't know how much is x, how much the length of this side is just 3x minus 2. This side is 5 minus x, okay? And this side is 2x minus 5. Now, I need to find the perimeter. How do you find the perimeter of a triangle? What do you do to these three sides? Add them all. So basically, what you need to do, 3x minus 2 plus 5 minus x plus 2x minus 5. Now, combine like terms, okay? Perimeter is around the shape.